Hi again. This is the second part of 6.3 where we need to find the sample size. This is a fairly common thing to need to do in real-world statistics, where what is the minimum amount of people that we need to sample in order to stay within a certain amount of error. Okay, so let's take a look at a particular problem. I have an economics professor that drives me crazy with statistics all the time, but here we have a situation where we want to estimate the proportion of Americans who own their own home. What sample size would we need in order to estimate within a 2% error at a 90% confidence? So when we have prior knowledge, we're given something like this in the problem. According to a previous study, like how I wrote that, according to a previous study, 42% of Americans own their own home. So we would use this as our p hat, and then our q hat would be 58%, right? Okay, so error is found by taking the critical value for z times the square root of p hat q hat over n, and you're solving for n. So your textbook was nice enough to actually solve this all backwards and give you a formula for n. So to find n, your textbook says the following: that the sample size needed would be all this nonsense right here. Okay, so our sample size for our problem would be n is equal to 0.42 times 0.58 times the critical value for a 90% confidence interval, which is 1.645, divided by your error. Now your error was given to you as a percentage, so make sure you change it to a decimal. So we're going to divide by 0.02, and the parentheses stuff needs to be squared. So 0.42 times 0.58, and then we need the 165 divided by 0.02. We need to square that, multiply everything together, and I get 1647 and some change. You always round up, no matter what. So we would need to sample a minimum of 1,648 people to stay within a 2% error, the 90% confidence, if we had prior knowledge. That's the big picture, if we had prior knowledge, okay? All right, when there is no prior knowledge known, no matter what the situation is, you're going to use p hat as 0.5, which forces q hat to be 0.5. So when we do this, how does that change how many we need to sample? So we're going to do 0.5 times 0.5, still the same confidence level, still the same error. We're just changing that p hat and q hat. So a little bit of number crunching, sprinkled with a little magic. Just kidding. And how about I just go ahead and put you on my tablet instead? Okay, that was awesome. Let's see, so I get 1691 and a little bit. Well, I know that in regular mathematics that would not round up, but in statistics, in order to get the minimum to work, you always round up. So that's 1692. So if you didn't have prior knowledge, it's going to force you to sample a few more people, but for whatever it's worth, you're given a formula to find sample size. We had to do this in section 6.1 and 6.2. This is not a new concept, just a new formula. Have a great day.